So this problem is about rational functions, so it's going to be a little bit different. First it asks us to find the domain of the function. So they give us a rational function, f of x equals 8 minus x over x squared minus 7x plus 12. The first thing you're going to want to do is factor that denominator. So x minus 3 times x minus 4. That's going to be the denominator. Now, if you think back to what we were doing on the previous problems, that means that x cannot be 3 and x cannot be 4. So if we're writing the domain, there's two ways we could write it. We could write it with set notation. It's a set of x such that x is not 3 and x is not 4. Or you can do interval notation, which is going to say all the numbers from negative infinity to 3, and then you can have all the numbers between 3 and 4, and then you can have all the numbers after 4. So this kind of goes along with the number line. So let me draw a number line real quick so you can see it. On the number line, you're saying here's 0, here's 3, here's 4. So you can have all the numbers that are less than 3, all of those numbers. You can't have 3, so we're not including it. That's why we have parentheses here. And you can't have 4. I'm trying to make a parenthesis. So you can have all the numbers in there. And then you can have all the numbers after 4. So it just excludes the numbers 3 and 4. So if they ask for interval notation, that's the way we write it. If they want set notation, it's the way on the left there. Or they could just ask it a different way. But okay, now I didn't leave myself enough room. Give myself a little more room there. Sorry. Now they say solve if f of x equals 3. Well, what that means then is you're taking the rational function 8 minus x over, now I'm going to leave it factored because I already have it factored. And we're saying, when does that equal 3? So I've got a rational function, and I want to know when does that function equal 3. The LCD is, I'll write the LCD over here, x minus 3, x minus 4. So you're going to multiply both sides by x minus 3, x minus 4. So on the left-hand side, x minus 3's cancel, x minus 4's cancel, and you have 8 minus x. On the right-hand side, you're going to have to multiply those binomials. That was already done because we factored them at the beginning of the problem. And now I've got to distribute this 3. I'm going to run out of room again. Okay. So I got a little more room. This equation now is a quadratic equation. So I'm going to go ahead and add x right there and add x right there. And I'm going to subtract 8. And then that's going to give me, because it's quadratic, I wanted to have a 0 on one side. So 3x squared minus 20x plus 28. Well, it doesn't have a greatest common factor. I have to try to factor that 3x squared minus 20x plus 28. So I'm going to go ahead and do the AC method. I'm going to write up here so I can have some room. So I'm going to go 3 times 28, which is what? 84. And I want to add to be a negative 20. So multiply to be 84, add to be negative 20. Well, 4 goes in. 4 times 21. And if I make them both negative, that would give me like negative 25. Now the signs will have to be the same. So I need it to be a little bit more than that. So will 7 go in? I think 7 goes in. 7 times 12? Well, that doesn't add up to negative 20. Does 6 go in? Maybe 6 goes in. I think I went past it. 6 times 14. I was not going to guess that right off the bat. Okay, 6 and 14 make a negative 20. They'll both have to be negative. So don't get discouraged. I mean, I was a little discouraged because that was number 84. I wasn't really familiar with it. Wasn't sure what it was going to be, but, you know, we found it. So negative 6 times negative 14, that equals 84. Double check it. Negative 6 plus negative 14 equals negative 20. Okay, so now we're going to have 3x squared minus 6x minus 14x plus 28. And once we find those numbers, it's all but the writing now. We know it's going to work, or we couldn't have found the two numbers. So we group, take out a 3x, take out a minus 14, and so it factors into x minus 2 and 3x minus 14. Okay. So what are the solutions? Well, one of them is 2, okay? So x could equal 2. And the other one's going to come from here. Now, how do you find that? You write 3x minus 14 equals 0. 3x equals 14. X equals 14 over 3. So the other solution is x equals 14 over 3. Now the directions for this part, way back up here, said solve f of x equals 3. They mean solve for x. So we found two solutions. X could be 2 or x could be 14 over 3. Now, what does all that mean in the world of functions? It means that if you plug in a 2 for x into the function, the original function, you're going to get out a 3. So this is like the input, and this is like the output. They told us the output this time, and we had to figure out the input. But there's another input right there that gets us the same output. So it says find the points on the graph at this function value. So what it means is there are 2 points. 2, 3 is 1 point, and 14 thirds, 3 is another point. So think of that input output, or x and y, or you're writing the point in terms of x, f of x. But we know what f of x is. They told us this part. They told us it was 3. And then there were 2 points that would get us a 3 for an output. So, all right, that was kind of a big problem. That factoring was a little tricky.